think how I want to open this up, I think we had a couple of 30 years ago, oh sorry, microphone, yes. 30 years ago, I think we had Tim Berners-Lee, who started the World Wide Web as a general framework. And we all know that, we all use it every day. And I think it was a very, very powerful message that came across at that very moment, which says essentially what happened is two computers got connected. And that was not just two computers, but that was also two pieces of information which got connected. And I think that was a very, very important point, that at that very moment, information could flow between those two elements. And what happened as the next step was that at some point, as humans, we could start to interact with that World Wide Web, right? So at one point, we had a desktop computer which allowed us to access that World Wide Web very fast, almost everywhere where we wanted it to, and suddenly had access to that information. Now, a second step happened in 2007 when the iPhone was introduced, and at that very moment, that information was available wherever we were as human beings. So wherever you went, you had a smartphone with you and could actually access all of that information that you had around you with the push of a button or the swipe of a finger, which was an insane development when you think about it as human beings. We had to go to read books or retrieve that information, a specific location on that planet, and now you just had it wherever you went. So the question that is up there, what is basically the next step? And the next step is to a certain degree described as connecting information now with the real world, because that information was contained within their own space. So information was somewhere in that cloud, somewhere in a virtual environment, but was not actually communicating back to the planet that we live in. And the interesting part in this is now when machines start to interact with the planet around us, then essentially the Earth or the planet starts to become a common interface. So we humans co-interact with the planet together with machines. So that as a concept changes completely the way we basically interact with machines, because suddenly we have a common ground to interact with them. And the first kind of points of that is already happening. You see augmented reality. This is an example of HoloLens, which in the end uses the world around you as a massive user interface or a massive display in order to give you that information, but location specific and around the world that you anyways live. So suddenly you don't need to have a display in front of you anymore, but you can just walk around and the information that you need is delivered to you through your environment, which is a massive shift. And another example is autonomous vehicles. We've all heard about them, but essentially what they do, that means a machine is now interacting with the planet without any human interacting with that. And that as a step is a massive, massive thing, because suddenly there is no, or that machine can start to alter the world around us as well, and is participating in something which was only reserved to humans before that. 3D printing has been, I think, a lot in the press a couple of years ago and got a little bit of a downwind. The reason why I'm putting this here is this was the first manufacturing technique where you had to have a digital file, otherwise it wouldn't work. So before that, with any CNC machine or any type of subtractive manufacturing, you had in the background maybe a drawing, maybe some measurements, but now there's shapes coming out that otherwise, if there's not a digital format, not a digital file, these shapes wouldn't exist and wouldn't be possible to manufacture. The World Economic Forum, or the more common term for this, is the Fourth Industrial Revolution, where essentially the physical and the digital world are starting to get interconnected with each other. And I think that's a very important step. What you see here is a 3D model, so this is not a 2D image. And another word of putting this is actually saying to make the world around us machine readable. And what does it mean to have a machine readable world is essentially that computers, software, machines, robots, programs, whatever it is, can actually start understanding what the world is. And that very moment, they can also start to interact. As a company, we start to call that concept a mirror world. And you have a similar concept which is coming from the IoT space where they talk about a digital twin. And the mirror world, in the end, is nothing else than an exact digital representation of the world that we live in, but not just the 3D data, such as Google Earth, for instance, did, not just the geometry, but everything linked together. So any type of data, any type of IoT data, any type of, for instance, pedestrian information, any type of contextual data about a building, what is the history about this building, energy consumption of it. So anything that you can find about this world into one piece together. The term itself was not invented by us. This was David Gelernter in the 1990s, actually 2 years after the World Wide Web was started. So no credit taken for this from our side. Now, how we as a company are doing this is we first of all start to collecting a very, very detailed 3D model to start with, because that 3D model is, so to speak, that very base layer in order to make that mirror world happen. If you don't have any 3D information, if you don't know where this house is, if you don't know where this traffic sign is, nothing works. The second step is that we take this 3D model, so this one big blob, and then we split it into all single pieces. So every house, every traffic sign, every road, every tree starts to get an own identity. So essentially similar to a Lego system, everything is split apart, and now you have, for every single thing that you can find in the real world, you have a single ID, and you have a single point of kind of convergence in that very point. And the third part is then to overlay this with other types of data. So at that very moment, if you, for instance, have a traffic sign, you can start to link a lot of information you can find about this traffic sign to that specific ID. So in that sense, it's not just a user interface, but it really becomes a massive database. So how do we get the context? A quick kind of background, just for those who are interested in a more computer vision task. So this is what is called in the industry a point cloud. So this is basically a three-dimensional representation of every pixel. So every pixel has a dimension to it. And in this case, not just a dimension, but also an identity such that, for instance, all trees, you can remove them, all the houses, you can remove them as well, and all the cars just at the click of a button. So like this, the whole data set is completely structured by default. What then happens is all of those different objects are basically taken out of context as well, and you can simply start to say, show me all the traffic signs that are in Zurich, for instance, or in Berlin, and then you just simply put up a database of all the traffic signs which have been recorded within that mirror world in the first place. So this is very, very similar to the concept of a digital twin from the IoT space, where essentially you have a digital representation of a physical object or process that then you can use for different purposes. To go a little bit, what is this infrastructure, or what is the mirror world really about? So this is not just the very first layer, which is basically the basis, which is the 3D model plus the data infrastructure I'm going to talk a little bit more about right after. It's also a data gateway for anyone to add data to the system. So this is something where anyone who has data, any car provider, any government, anyone who has collected data about the real world that we live in can essentially participate in the system. They can add this data, they remain the owners of the data, they can define the privacy rights, they can define everything about this data that they want, and might restrict the usage to only those people coming from the same organization, or maybe only to the people coming from the same country, or make it completely publicly available. And then you have the third layer, which is an SDK for developers, which take this entire data set, this entire mirror world, and start to build applications on top of it. So we call them mirror world applications. What could this be? This could be, for instance, the simulation of autonomous vehicle. This could be an architect or something like AutoCAD, which is using software in order to build houses and then visualize them. This could be something like the controller for a drone, and this could be something like an urban planning studio that wants to understand the bigger things of their city. All of this is then made available in an app store where you can discover those mirror world applications on the one hand, and on the other hand, also the data points which have been added to this in the first place. So this as a whole is essentially what we today call the infrastructure of the mirror world. So when you see this in a more concrete example, here you have a portion of Zurich. This is the main station there, where you have the 3D model as a base layer. You have the weather, which is changing now, so you see suddenly it's raining. You have reflections on the street, which is coming from this. You have the cars driving around. You have pedestrians walking around. And all of this data is now in one spot, so you can start to run analytics on it or make predictions or use it for instance, autonomous vehicles to train their algorithms in the first place. This just as a small example. Now the interesting part. So this was just an introduction to get you a bit up to speed what the mirror world is in the first place. And when we started to look at this and said, okay, how do we now ensure that the data that has been added, for instance, by a private person is maintaining with them and is actually routing with them, because you have this massive blob of data which is all linked together and is insanely powerful in that sense. How do we actually manage all of this? And I think the very, very first point for us was super important to say data ownership has to maintain with the one who is contributing data in the first place. I think we're all aware that all the big World Wide Web giants in that sense, the Facebooks, the Googles, and so on, they had one big trick, is that they basically own the data that you as a user participate into the system. So at that very moment, that doesn't make much sense, because you actually give your data into this, the system profits from it, but you don't have any control over this data. So in any more responsible kind of move forward, the data ownership has to remain with the one providing this data in the first place, which is very unconventional, specifically when you go into the GIS type of industry where everyone is basically just selling that data in a one-off shot, right? So a government maybe wants to have a 3D model of a city, they purchase it, and then the ownership of the data is transferred from the originator to the other person, and then it's there, it sits there, and it's not getting reshared with anyone else, because you are the owner of this data, and this is actually your proprietary advantage. The other part is authentication, and this is really, really important and far beyond what we're doing. So whenever you want to control the access rights of different data types, whenever you want to say, you know what, my data is only available now to my family, for instance, because I want to share my location just with the people that are loved to me, and that's fine, but I don't want to share them, for instance, with the government. At that very moment, the different users participating in this mirror world, they have to be authenticated in the first place. So you have to recognize who is actually, or what is actually accessing this data in the first place. So only if you have a decentralized identity system, it can happen that you can control who is having what data at what point in time. To give you a little example, if an autonomous vehicle, for instance, is delivering or making a delivery, at that very moment, you might enter into a situation where the owner of a house has defined a specific location where a package should be dropped off. And a robotic car is going there, and at that very moment, the robotic car has to communicate with the house in that sense in order to deliver that package in that specific location. For this, you might want to open the gate that this little pedestrian sidewalk robot can actually enter and actually reach that location. So in at all very moments, first the robot has to identify, then the house has to identify, and they have to agree that now this package is delivered to a specific location. So at that very moment, they have to have that consensus that this is actually what has been agreed upon at the order, and that everyone in the whole system is actually who they say they are. The next part is that data privacy. Of course, we're sitting in Europe, and all of this data is, or some of this data is also, from a data privacy point of view, not that easy. So what we do as a company is already, when we build these 3D models, everything which is cars, everything which is pedestrians, everything which is data privacy related, we're taking this one out. So we're not reconstructing it as a exact measurement in that sense, but we're collecting this data or re-putting then the pedestrians, as you saw before, or the cars in from pedestrian-specific data or from traffic data in the first place. So this was not something which was captured. This was something which was then put back through simulation into the system. But in general, data privacy, everyone who is owning the data should have the right to actually decide what is the data privacy setting of that specific data that I'm sharing with, and with whom am I sharing it, and for what purposes. Governance is going to be something which is going to be very, very important, but also very tricky to achieve. And to give you a little bit of a small example or a small glimpse on what this is going to look like, this was a a digital art sculpture which was placed by an artist, and it received virtual vandalism. So other artists started to alter that virtual data or that virtual art piece. And now the question is this allowed? Is this something you can do? And in the physical world, this is clearly defined, but in the virtual world, this is not. And this goes far beyond that. That goes to the point where what if an autonomous vehicle delivers something which is completely wrong? What if an autonomous vehicle makes an accident? What if I, as a HoloLens or as an augmented reality provider, suddenly starts to block out certain traffic signs? Right? We're now in a scenario where we're not yet autonomous driving. I'm driving through a speed zone 30, and I'm, as an app provider, altering that speed zone 30 into 50, and you get a fine from someone. This is something which is allowed. This is something that I, as an app provider, or I as an experience builder, can actually alter to that very degree. So that very moment, you have the question of the virtual world is interacting with the physical world, is altering it to a certain degree. And the question is this allowed? If yes, everything is fine. But who says in the first place what is allowed and what is not allowed? Because that very moment, the digital world for the first time starts to really alter the physical world. And now this has always been indirectly, right? This has always been through your data has been leaked, or this has been altered, or maybe your bank account has been hacked, which of course has physical implementations, but not to that very degree as it has in that new, or with that new fourth industrial revolution. Let alone speak about an autonomous vehicle which might go completely rogue and drives into the mass of people. Whose fault is it, right? So these are going to be questions which are very hard, but we as a not only society, but also as an industry have to start attacking this and have to start actually asking those questions, work together maybe with the politicians, maybe with the communities, and start to find answers for this. And then the last part that is also important, which a lot of people are not realizing, actually one of the main users for this are machines. So we have to start thinking really about user interfaces. And yes, we have web APIs, of course, but one of the main drivers of a mirror world and one of the main users are going to be machines. And what are the right user interfaces for those machines? Which up to date has always been very, very human-centric. And that's going to be the next step to actually make this widely adoptable. This just as a little kind of gimmick, we did a 24-hour daylight simulation over the city of Zurich. So there was not a drone like hovering above there to watch at this. And I want to open the conversation and take questions from your side. Thank you very much. Yes.
You discussed the concept of the people who provide the data are the owners of the data. How do you reconcile that with a tree or a stop sign? I suppose could be with the government, but a tree or a mountain.
Yes.
Do you own the data because you had the satellite to grab it?
This is really interesting, right? So this is the difference between. So the current legal system is that the one who is producing the data, so in that sense the 3D model, is the rightful owner of it. But that's exactly the philosophical question: who is the owner of then all the data in the background? So it gets a bit more, or it's a similar question than. There is, for instance, in Switzerland, the government knows the age of the tree, they know the type of the tree and all of this information. Do they own that data, which is then added to this entity? Is an IoT provider now with a traffic sign, for instance, who's collecting certain information about a traffic sign? That one is then obviously, or should be probably the owner of that specific data. But this is exactly the interesting part, that at some point you will go and have the same kind of data hub, which now could be a traffic sign or a tree, and has multiple owners depending on the data source where it's actually coming from. Yeah, and the same is going for instance, landmark buildings. Like you have a beautiful church, or you have the Eiffel Tower. Is this something which is belonging to the architect? Is it something which is belonging to the city? And today it simply has not been answered. There's no like clear answer to that, and I think that's what we have to slowly start finding. anything else? So otherwise, I'll go up into the break. Thank you very much.